Good day and welcome to Chemistry Tutorials with Tutor Emmanuel Oyedun. And today we are going to be solving this redox reaction. Now this is an example of a reduction oxidation procedure reaction and how do we balance this kind of reaction. So follow me carefully, because in redox reaction you must get to the point where both the charges are balanced and the number of atoms are what? Balanced. And we are going to be using the half reaction method in balancing this redox reaction. Okay, so we are going to write out the equation into their respective processes. So I will have Mn4 direct to Mn2 plus C2O4 2 minus to give CO2. Okay? So I've splitted the reaction. So how do I identify which one is oxidation, which one is reduction? Now, anytime there's a reduction in the oxidation number, of course the oxidation number of the species here is +7, here will be +3, here is +2, and here is +4. Okay, how do I get +7? Very simple. I will say Mn plus the oxidation state of oxygen is -2. I have 4 molecules of oxygen is equals to -1, the charge unit. By the time I say Mn plus -8 is equals to -1. Mn is equals to -1. This one will have become, this one will be Mn minus 8 is equals to -1. Mn is equals to -1 plus 8. That will give me +7. If I do the same thing for all other species, I will get all these values that I've mentioned here. So from +7 to +2, that is reducing, and that process is definitely reduction. And from +3 to +4, there's an increase, and that process is known as oxidation. So I will look at the oxidized and reduced atoms. Are they balanced? I have one manganese here, one manganese here. That makes it balanced. I have 2 carbon here, but 1 carbon here. So all I need to do is to actually to balance the carbon atoms. So having done that, I will balance other atoms present, adding water where it is necessary. So for this reaction here, there's oxygen here and there's no oxygen here. So I'm going to add hydrogen to this side and add water to this side. So I will have MnO4 minus plus H plus to give Mn2 plus H2O. The other atoms here is already balanced, so there's no point adding water here. 4 oxygen, 4 oxygen. So there's no point adding water to this. So I'm still going to leave this as C2O4 2 minus to give 2CO2. So I have 2 hydrogen here, 4 oxygen here. So let me put 4. Oxygen is 4, oxygen has been balanced. 4 times 2 8, so 8 hydrogen. So I've balanced this, and this one too has what? Been balanced. I will now bring in the charges. Manganese was +7 here, and in transition, the oxidation number changes to +2. That means it has gained 5 electrons for that to happen. Because reduction process, a process where electron is being gained. Minus plus 8H plus, MnO4 minus plus 8H plus 5 electrons. We give Mn2 plus 4H2. Again, 5 electrons came about because the oxidation state changes from +7 to +2. That means 5 electrons was involved for the oxidation number to have changed from +7 to what? +2. And for this one, now, in this case, because the oxidized atom was balanced, that means there are 2 species of the oxidized atoms involved. It means the number of electrons involved in, I have to multiply it by what is used to balance it. Now from +3 to +4, that's an electron involved, right? But because I have 2 of the oxidized species involved, it's going to be 1 electron involved multiplied by 2. That each one of them supply 1 electron each. That makes it 2 electrons. So C2O4 2 minus to give 2CO2 plus 2 electrons. So I'm going to equalize the electron. And how do I do that? The best way of doing that is to borrow a concept from simultaneous equation in mathematics. And what do I mean by that? So I would say 5 electrons is there and 2 electrons is there. So I will multiply this equation by 2, this equation by 5. The number of electrons here I will use to multiply this equation, and number of electrons here I will use to multiply this equation. That is borrowing the concept from simultaneous equation. So we have 2mn O4 minus plus h times 2 is 16h plus 10 electrons. So to give 2mn 2 plus 8h2o. And 5 is multiplying this. We have 5c2O4 2 minus to give 10CO2 plus 10 E minus. So that way, the electrons is going to strike out. It will cancel one another. So I'm now going to add up the half reaction now to make up one redox process. And how do I do that? So we have 2MnO4 minus plus the other reactant here, 5C2O4 2 minus. Now, I'm going to bring hydrogen to the side where it's multiple. Okay, hydrogen is only on this side, plus 16H plus, 16H plus, all to give, now this arrow, sorry the body is limited here. So this is the product side I'm about to write now. To give 2Mn2 plus, okay, plus 10CO2 plus 8H2O. Okay, so here is now the balanced redox reaction. How do I know if it's balanced? Let me check the charge. The charge on the reactant side now we have 2 multiplied by minus 1, that's minus 2, plus 5 multiplied by minus 2, minus 10, plus 16. That will give me what? Minus 2, minus 10, that's minus 12, plus 16, I have 4. And here I have 2 multiplied by 2, that's 4. 10 times 0 is 0, because there's no charge here. 8 times 0 equals 0. So the charges are also what? Balanced. And since charges are also balanced, it means this is the balanced redox reaction for this. I believe you got the knowledge on how to balance redox reaction. Now, kindly follow my page or subscribe to my channel as the case may be, depending on the social media network you are watching this tutorial from, so that you can get notification on the next video that will drop. See you in the next class.